thanks for being here. It's early already, but I see we've got nice turnout, which is great. Like Mike said, I've been around Saipan doing work on pollution problems, mostly heavy metals, sometimes PCBs and petroleum hydrocarbons and things like that. And most of my work is confined to the western side of the island, because that tends to be the most populated, and that's where all the action happens. You know, that's where the U.S. invasion came. The 70 years ago, U.S. invasion, 1944, long time, before my time. Just so lots of ordnance exploded and unexploded, lots of military hardware of various sorts or another. Many of these things have quite toxic chemicals in them, especially some of the heavy metals. Back then, the artillery shells that were used by the U.S. government had mercury fulminate as the primary explosive. And these were also in percussion caps on bullets as well. They changed it to lead azide after a while, not because it's less toxic than mercury, because it isn't, but it's just more stable. And mercury was running out. We're using so much mercury in the States for warfare during World War II. They were running out. They couldn't buy it fast enough. So they used lead azide as the primary explosive. So every time a shell detonated, there were several grams of this stuff liberated into the atmosphere, into the water, onto the land, etc. And that's really where my interest lies, because up until quite recently, like I said, most of my work took place on the western seaboard. And during some of my sediment transects that I did from the shoreline right out to the barrier reef area, we would sometimes find increased levels of mercury as you get further out. Probably as a result of the initial range finding. Don't forget the battleships and the whole U.S. armada that showed up 3 or 4 days before the invasion were 10 miles offshore, for fear that if they came any closer, there would be mines in the water they might run into. So a lot of range finding, you know, they overshoot and they undershoot. So some of the shells get into the lagoon, some go beyond the Japanese fortresses stationed along the coastline until they get it just right. So lots of shells missed, overshot, and some landed in the lagoon. Some detonated, some didn't. Approximately 10% of artillery shells don't go off on average. So I know we've probably all seen live ammunition in parts of the lagoon, and lots of detonated ordnances as well. So I kind of exhausted the areas on the western coastline, so I decided to go east. And what I'm going to show you is, I think I've been through most of that. What I'm going to show you is a set of dumpsites that we have checked on the eastern side between Agingen Point, which is essentially not east, it's south. But the whole, I should have flicked through these earlier. Here we go. So Agingen Point here, not strictly east, but if you put the line right up there to the bankside, it kind of splits the island into left and right. So the sampling sites that I visited between Agingen and Bankside. Now each one of those markers doesn't indicate a dump. Some do, and some indicate areas where there's drainage areas that drain into the ocean, and we suspect, or we know of, some previously unidentified dumps in those general locations. So even though you've got 32 sampling sites, there weren't actually 32 dumps per se, just some were suspected. Now, in most cases we took soil samples, but in some cases we took beach sand as well. And you'll see the differences in the results as we, I will tell, well, I've got it marked on the diagrams, which are sediments and which are soils. If they're sediments, they were collected in nearshore environments. If they're soils, they were collected on land. Okay. Some pretty pictures first. In fact, most of this presentation, you'll be glad to know, Mike, it's pretty pictures, so I can get through it very fast. Banzai Cliff, this is actually a wartime photo of them dumping unexploded ordnance over the, there's a tipping point there, it's still there. I don't think this little thing is still there, but you can see the concrete area where the trucks will back up and tip live shells and what have you into the ocean. And that was a practice, actually, which is kind of common in various places. You know, these wastes, military waste excesses they had left over, including demolition materials from the rebuilding effort, the road building, etc. They were discarded, usually by bulldozing over the cliff or burying in caves, or in the case of munitions, detonating or burning on land. Usually in remote areas, because most of the population is on the western side, so the eastern side was a favored spot for burning some of these waste products. Okay, so that's Banzai. Gingan's got much the same. Now, I'm never sure, perhaps someone can help me out here, whether that, because a Gingan point was a civilian dump for, and I don't know how, if you say Gingan or a Gijin, I'm not sure. And forgive me for those mispronunciations too, because it's a little different on Saipan than it is in Guam. If it's a Gijin, okay. If it's a Gingan, okay. But either way, you know what I'm talking about. But I'm not sure whether that is a leftover from the aftermath of World War II, where they were dumping stuff over the cliff, or it was more recent, I don't know. But there was certainly dumping going on there. And no, I'm not contemplating jumping off, just looking down. It's pretty sheer. I've heard stories of refrigerators turning up in Tinian from domestic waste that were discharged over there during the 60s and 70s. And if you go down there at low tide, the tipping point is around the corner over here. So we're now down in the little bay area of the Gingan Point. There's all sorts of rubbish here. Old car engines, electrical wires. In fact, I think I got some close-up shots of some of the, look at this, I mean, there's a whole stack of that. So you can expect copper, for example, in the sediments, which of course there is in large quantities. So there's all sorts of interesting debris there, which keeps people like me in job security. Because I look at whether this is being taken up in biota, particularly biota that may be consumed by the local people. More of the same. I can get a point. Now, I think you pronounce that Obsen. Is that right? Obsen? Not Objan, but Obsen. Someone say yes? Obsen. Obsen. This was a burn site. The wastes were dumped over a kind of a ridge into a little gully, and there's all sorts of interesting stuff here. Most of it's overgrown. An abundance of bottles, Coke and beer bottles, seem to be a predominant sort of waste there. And this is kind of indicative of the burning, intense heat. So there's some detonation, there's some incendiary devices there, there's some indication of ordnance being exploded there. Military waste, there's an old Listerine bottle there. There's this little piece of pottery that had United States Medical Department. So medical waste as well. That site particularly polluted with all sorts of interesting heavy metals, cadmium, lead, silver, copper, zinc, the whole plethora of common metals that you expect to see in this sort of situation. Lots of biota there too. Haven't looked at things wandering around there, but maybe there are biological transfers of these contaminants in the soils from that particular area into food resources or particular plants that may be used for consumption, or maybe you still have people on Saipan that use some of the plants for medicinal properties. We certainly do on Guam, so they do have people like that as well. So all that needs to be explored at some stage. There's a another, looks like an aerial bomb there. Not this guy, that's Dave Beneventi. But here, you can see it lights a little off, but you can see it's just a casing of a bomb. And a big one too. The interest here, there was no river or stream taking possible elements or sediments or soils which would be suspended during rainstorm into the ocean. But it's karst, and so it's porous. And it's quite likely that some of the metals that came off of this sort of debris may have leached down through the karst system into the ocean. So it's certainly an area which I thought was quite interesting. There's the gully there at the end. This is Naptown Point. It's called Obzam Dump, but this is Naptown Point area. Certainly looked like it was going to be an interesting site. Naptown, I don't know if you've been up there, another burn area where you could see huge amounts of detonation. Frap, that's like fragmented iron lying around. Look at this over here. Of course, you can get stuff like this right close to the ocean. It means during storms, wind-blown dust, and they may even dumped over the cliff into the ocean. Lots and lots of it. Again, the indication that there was burning going on there. Now, to assess the data on every one of these sites, we took soil samples or sediment samples and analyzed a whole suite of metals, 9 in total. But there were only like 5 that I was particularly interested in. We call them the rogue 5. Copper, cadmium, zinc, lead, and mercury. Of those, 2 are essential. And so most organisms can regulate them. They have homeostatic control over copper and zinc, for example. And even though copper is somewhat toxic to certain organisms, like plants, to most organisms it isn't, because they can control their uptake. Cadmium, mercury, and lead, on the other hand, are not essential. So we don't have the same biological mechanisms for regulating them. And because they're chemically similar to things like copper and zinc, they kind of piggyback on the mechanisms that actively take that metal up from, usually from ingestion. There are 3 documents that I used to evaluate the findings from soil analysis. This US EPA document, that contains some background information on soils. Now, Saipan soils are probably very different than US mainland soils, but there was a whole range of soils there, so I just sort of put the range down and kind of went from there to get some idea what background was. But I do have some background data for Saipan as well. US EPA 2008 Evaluation of Environmental Hazards. That's a document which is used by DEQ to assess soils, either for non-restricted purpose or possible residential areas. They have tables, quick look-up tables, as they call them. You can see a bit in there, look-up tables, where you can assess the levels that you find in your sample with the levels that are printed there. And they have these SRS values for, there it is there, shallow residential soils, SRS, environmental screening levels. So these are screening levels above which, if you get a sample that exceeds the screening level, it really means you need to go back and evaluate the site a little closer. Possibly it's getting into groundwater, possibly it's a human health problem if it's in a residential area. Possibly it's ecologically significant if it's in an area where you have like protected species, for example. Or possibly it's significant with respect to uptake by aquatic organisms. Then there's this final document which is equivalent to this document which is currently used by DEQ, except this is for ecological soil screening. So less of human health and residential planning development, and more on the protection of the critters in the soil itself. And there are various species that have been used to develop these eco screening soil levels. And the most sensitive receptor is the one that I have used in every case for the metals I've looked at. Okay, let's have a look at the data. Of the 32 sites we looked at, 10 of those sites exceeded shallow residential soil screening levels for one or more metal. And most of those sites there had fairly high levels of all metals, but the metals in parentheses are the ones that exceeded the ESL screening level for shallow residential soil. A gingham point, lead, a gingham point down here. That's a gingham dump area. That's actually on the top of this little point, where there's evidence of a dump still in terms of soil. So a fair amount of stuff there. But actually in the water here, this is a sediment value. The gingham point offshore, just there. Huge amounts of lead. I mean, literally tons. And I'll show you some of the values in a minute. Up here, lead again a problem. And Upton dump again. We'll go back to those. As far as the US EPA Eco SSLs, all the sites, every single one of them, had at least one or more of the levels that we looked at that exceeded the US EPA Eco SSLs. Interesting. Here's some numbers here, so you can. This is the average value for soil for these elements. Now these are parts per million or micrograms per gram, except for mercury. Mercury is a little different. It's in parts per billion, so it's in micrograms per kilogram or nanograms per gram. So it's a little different. Here's your Saipan SRL ESLs, what the DQ use. These are the numbers they have. These are the site exceedances of each of those numbers. So there are two sites, for example, that exceeded the Saipan shallow residential soil screening value for silver, 12 cadmium and so on. And the study maxima is right here. This is the highest value we found. These are average values in soil. These are the highest values we found. Copper doesn't go above about 100, but we had 11,000 at one particular site. Similarly with mercury, over 1,000, and rarely goes above 60 in normal soil, and so on. This is the huge value of lead. That was at a gingham point, the sediment value, 2,000. It's getting up there. I mean, that's kind of worrisome. And then you have the same down here with your interim eco SSL, the US EPA ones. These are the actual values. These are the site exceedances. And these are the maximum. Okay. So in summary, samples collected from shallow, well-drained soils on limestone escarpment and plateaus show some contamination for one or more metals. But the elemental composition was different between different samples, of course, as you would expect. Tendency of the SRL and ESLs, we've been there already. The Upton site was my favorite. That was the one with a bit of the pottery shard with the medical waste, the medical officer shaving bug or something. That was my favorite because it had the highest concentration of all the metals. A gingham point was another one because it's hugely contaminated with lead. I mean, really, enormously so. The good news is it doesn't appear to be getting into the biota in the sort of extent I would have expected. It's there, but not at enormously high levels that make you think, oh my God, we've got to do something. So the lead is in largely in unavailable form in the sediments at the moment, being slowly released. There's high amounts of copper there from those cables you saw. There's some mercury and zinc, at least 10 times higher than background. Okay, we can do that one. After finishing this, you know, the obvious question was, is any of it moving in the biota? So the follow-on study was directed towards that. We were looking at organisms that may be downgradient from these dump sites that could possibly be accumulating the metals. You can do that one of two ways. You can sort of do it haphazardly, picking things that maybe people eat, or you can look at tried and tested biomonitors. It used to be called bioindicators, and when I grew up, doing my PhD on this sort of stuff, bioindicators were called bioindicators, but the name changed nowadays, but old habits die hard. They are called biomonitors now, but I still call them bioindicators. So a bioindicator is an organism that will actually tell you whether there's been a change in ambient conditions.